City Administration Education Bureau in collaboration with Addis Media Network. I'm Teacher Mamu. I will teach you mathematics. Well, today we will learn about some theorems regarding circles. Basically, we will try to touch 3 theorems on circle. Okay? The first theorem that we will see is a theorem which deals about inscribed angle subtended by a semicircle. The second theorem that we will see today is about angles subtended by the same arc. And the third theorem will be about theorem that talks about the angle between 2 intersecting chords, right? So before we proceed to the present lesson, I will remind you some of the points that we have seen yesterday, right? So in our previous lesson, we have seen a certain theorem which deals about cyclic quadrilateral, okay? Suppose we have a certain cyclic quadrilateral, a quadrilateral inscribed in a circle where the vertices are on the circle. Say we have a cyclic quadrilateral, okay? One of the theorem that we have seen in our previous lesson is the pairs of opposite angles in a cyclic quadrilateral is supplementary, right? That means if you have points A, B, C, D, assume these points are on a circle and they are the vertices of the quadrilateral. So that theorem tells us the sum of the angle A and C forms 180 degree, okay? Supplementary means the sum of the 2 angles is 180 degree. At the same time, D and B also forms 180 degrees, so that we call them B and D are supplementary angles, right? So that was the point of discussion. The proof was very simple to understand, and you can easily prove this theorem, right? So the procedure that we use to prove this thing is we take angle A. The measure of angle A is, as you all know, the measure of angle A is half of the arc subtending it, right? You all know that the inscribed angle is half of the measure of the arc subtending it. So angle A is half of the degree measure of BCD, okay? BCD. Again, angle C is inscribed angle. This angle is subtended by BAD, okay? So measure of angle C is half of the arc subtending it, which is BAD. Now, if you directly add these 2 angles, you will get measure of angle A plus measure of angle C is equal to half of the sum of these arcs. Half is common, so you can take it out 1/2. Then inside the bracket, you will have BCD plus BAD, okay? Look, here BCD refers to this portion of the circle, and BAD is this part, okay? As you can see, these 2 curves or these 2 arcs forms a complete circle. So you all know that the degree measure of a complete circle is 360 degrees. Therefore, in place of this, you can substitute 360. So half of 360 degree is 180 degree. Okay? So from this, we understand that the sum of A and C is 180 degree. So we can say A and C are supplementary. Okay? This was the proof that we have seen yesterday. Similarly, you can follow this procedure and apply the concept of inscribed angle to drive or to prove the sum of angle D and B forms 180 degree. So that you can say that B and D are supplementary angles, right? So based on this theorem, we were able to see two basic examples in cyclic quadrilateral. Just if you have a certain circle with a cyclic quadrilateral, okay, if you have these kind of things, say the angle that we have here is x plus 10, and this one is 100. Assume this angle is 30 degree, and this one is y 2y plus 40 degree, right? Based on this information, if you are asked to find x and y, you need to apply the concepts that we already observed, right? So you need to remember the pairs of opposite angles in a cyclic quadrilateral is supplementary. That means these two, the sum of these two must be 180 degree, right? That is the first step that you need to write. So to find the x value, you need to take the sum of these two, x plus 10 degree plus 100. They are supplementary, therefore the sum of the two is 180 degree, right? Now collect like terms. 10 plus 100 is 110, so x plus 110, x plus 110 degree is 180 degree. Okay, now you can take 110 to the right or subtract both sides 110 degree. Then x becomes 180 degree minus 110 degree, and this difference is 70 degree. Okay, so in this figure, the value of x is 70 degree, right? Similarly, you can also calculate the unknown variable in this cyclic quadrilateral. So how do you calculate the value of y? Again, you need to apply the concept that says the pair of opposite angles in a cyclic quadrilateral is 180 degree or supplementary. That means take these two, take the sum of these two. That means 2y plus 40 degree plus this 30 degree is 180 degree, okay? Now, the sum of these two is 70, okay? So this becomes 2y plus 70 degree is equal to 180 degree, okay? So if you take this 70 degree to the right side, then you will have 2y is equal to 180 degree minus 70 degree. Okay, and this difference is 110. So 2y becomes 110 degree, right? Lastly, you will divide this equation both sides by 2 and obtain the value of y. So dividing both sides by 2, the value of y becomes 55 degree. Okay, when you divide this number, it becomes 55 degree. So this is how you can apply the concept of cyclic quadrilateral to find the unknown variables in this kind of situation, okay? So today we will focus on 3 basic theorems, okay? The first theorem that we will be discussing today is theorem that talks about inscribed angle subtended by a semicircle, okay? An inscribed angle subtended by subtended by a semicircle, is right angle. Okay. It's very simple to prove this fact. Okay. In our former class, we have proved that the inscribed angle is, the measure of the inscribed angle is half of the measure of the arc subtending it, right? So here we will apply that theorem directly. You will not have too much calculation to prove this, okay? So simply, if you have a certain circle, okay, and assume our inscribed angle is A, B, C. Say this is A, this is B, this is C. Okay, these are chords. So if this arc AC is a semicircle, because it says inscribed angle subtended by semicircle, this angle should be subtended by a semicircle to be a right angle. Okay, so if AC is a semicircle, if arc AC is a semicircle, we can conclude that angle B is a right angle, right? How you can apply the concept of inscribed angle. So since the degree measure of angle B is half of the arc subtending it, that is arc AC, since arc AC is a semicircle, the degree measure of a semicircle is 180 degree. So in place of the measure of arc AC, you can substitute 180 degree, right? So half of 180 degree is 90 degree, right? So this way you can show that, or you can prove that an angle inscribed in a semicircle is 90 degree, right? So let me show you a simple example to explain this theorem, right? So the first example, consider the diagram shown. The diagram shown below. Okay, consider this diagram. A circle together with some chords intersecting at point A, B, C, and assume AC is the diameter. Okay, assume AC. Okay, AC is a diameter. Okay, you have here a certain inscribed triangle with the condition AC is a diameter. Here we have some more things. Assume the degree measure of arc AB is 2x degree, and the degree measure of arc BC is 3x degree. Here, find number one, the measure of angle B, and number two, find the value of x. The value of x. Okay? So, in the first example, in this example, you have this figure. In this figure, AC is given, which is a diameter of a circle. The other thing, a certain portion of the circle is given by 2x degree and 3x degree. So you are asked to find two things. The first thing that you are asked here is to calculate the degree measure of angle B, and the second one is finding the value of x. Okay, so to calculate the angle B, okay, the degree measure of angle B, you need to directly apply the theorem that we already proved, right? We already said that an angle inscribed, an angle subtended by a semicircle, an angle subtended by a semicircle is 90 degrees, okay? Because here AC is a diameter. You all know that the diameter of a circle divides the circle into two equal parts. So AC will be a semicircle, which is 180 degrees. Its degree measure becomes 180 degrees. Similarly, the remaining portion of the circle is a semicircle, and its degree measure is 180 degrees. So here, the value of the degree measure of angle B is 90 degrees based on the theorem we already proved, right? So no more calculation, you can see and respond the first part based on the theorem that we already proved. When we come to the second one, the second question here is find the value of x. Okay, how do we calculate the value of x in this circle? Here, you need to consider the whole portion of this arc, okay? Arc AB and arc BC together forms a semicircle. Therefore, the sum of these two arcs will give us 180 degrees, okay? So 2x degree plus 3x degree is equal to 180 degrees, right? So the sum of these two is 5x, okay? 5x degree is equals to 180 degree. And lastly, you can divide both sides by 5, and the value of x will be some number, okay? When you divide 180 degree by 5, you will get 36. So x becomes 36 degree, okay? So this way you can answer questions like this, okay? So let's see the next theorem, okay? We have already seen about theorem that deals about an angle subtended by a semicircle. So keep in your mind that an angle subtended by an inscribed angle subtended by a semicircle is 90 degrees, okay? So let's see the second theorem. So the second theorem that we have for today is an angle subtended by the same arc are congruent, okay? An angle subtended by the same arc are congruent. Okay, so let me show you the geometric interpretation of this theorem. Okay, if you have two angles, inscribed angle subtended by the same arc, okay, this angle is, okay, an inscribed. Okay, you can make it an inscribed angle subtended by the same arc are congruent. So geometrically, it looks like this. If we have a circle, suppose there are two inscribed angles, okay? Say this is A, B, say this point is, we don't need this point, okay? We don't need this point. Say this is C, D, okay? Now, observe that ABC is subtended by arc AC, okay? And ADC is also subtended by the same arc AC, okay? So if these two angles are subtended by the same arc, then the two angles are congruent, okay? It's very simple to prove it. So let's prove this fact. The measure of angle ABC means this part is half of the degree measure of arc AC, okay? Because by definition, an inscribed angle is half of the arc subtending it, okay? The measure of the inscribed angle is half of the degree measure of the arc subtending it. Similarly, the measure of arc ADC, arc angle ADC is equal to half of the measure of arc AC. Okay, so since these two angles are equivalent to half of the measure of arc AC, by transitivity, we can say that the measure of angle ABC and the measure of angle ADC are the same. Okay, this way we can prove this theorem. Okay, so based on this theorem, we will have certain examples. Let's see what the examples look like. But keep in your mind that an angle or an inscribed angle subtended by the same arc are congruent. Okay, good. So consider the figure below. And find okay, let's see what our figure looks like first. So assume there are different chords intersecting on a circle. Say this angle is 2x plus 10 degree, and this angle is 70 degree, and here this angle is 80 degree, and here 2y plus 20 degree. Okay, so this is the figure. Okay, this angle is 70 degree, this angle is 2x plus 10 degree, here this is 80 degree, and 2y plus 20 degree. So from this figure, find the value of x and y. Okay, here to calculate the value of x and y from this figure, you need to apply the theorem that we already stated, right? So clearly this angle and this angle are congruent, because we already proved that an angle subtended by the same arc are congruent. Okay, as you can see here, this angle and this angle are subtended by the same arc. If you want, you can call it A, B, C, whatever you like. A, B, C, D, right? So this angle A is subtended by arc BD, and angle C is also subtended by arc BD, so they are congruent. Okay, so we will have this result. So the first one is 2x plus 10 degree is equal to 70 degree. Okay, these two angles are the same. So this becomes 2x is equal to 70 degree minus 10 degree. And this difference is 60 degree. So 2x becomes 60 degree. Now you can divide both sides by 2, then obtain the value of x. So x becomes 30 degree. Okay, the unknown variable, one of the unknown variable in this figure should be 30 degree. Okay, x is 30 degree. Similarly, you can observe that angle B and angle D are subtended by the same arc AC. Okay, so you can assume that 80 degree and 2y plus 20 degree are the same. Okay, so this is the first result from the previous theorem. So the second result will be 2y plus 20 degree must be the same as 80 degree. Okay, now you can solve for y. Okay, collect like terms, and this becomes 2y is equal to 80 degree minus 20 degree, which is 60 degree. Then divide both sides by 2. Unfortunately, we will have the same result. So y is also 30 degree, okay? So this way we can calculate the unknown variables if we have some unknown variables, right? So this is how we apply the theorem that states two inscribed angles obtained by the same arc are congruent, okay? So now we will have one more theorem, which is about angles formed by two intersecting chords, okay? So the last theorem is about angles formed by two intersecting chords. Okay, this theorem tells us an angle formed by two intersecting chords, or the measure of an angle formed by two intersecting chords is equal to half of the sum of the measure of the arc intercepted by the angles and the vertical angle, okay? So the measure of an angle formed by two intersecting chords, inside a circle is equal to half of the sum of the measure of the arcs intercepted by angle and its vertical angle. Okay. Here, I can make it easy by showing you the geometric representation of this theorem. For example, vertical angle. Yes, thank you. So, this theorem says the measure of an angle formed by two intersecting chords inside a circle is equal to half of the measure of the arcs intercepted by the angles and its vertical angle. Okay? So, geometrically, this theorem can be represented this way. Suppose there are two intersecting chords which are intersecting inside a circle. Say these are the two chords. Okay, say one of the chords is chord AB, the other one is CD. Assume these two chords intersect at some point E. Okay, this point E is the point where these two chords intersect. Okay, so based on this theorem, an angle formed by these two intersecting chords, the angle can be this one or this one. Vertically opposite angles are congruent, so it doesn't matter which one you are taking. So if you are considering this one, the angle BEC is half of the measure of arc AD plus arc BC, right? So based on this theorem, we are saying that the measure of angle BEC is equal to half of the measure of arc AD plus arc AD plus BC. Okay, now I will try to prove this thing very shortly, right? I will show you how this result can be proved. Look, to prove this thing, to prove this theorem, let us construct or let us join some other points. If you join this D and B, you will have some other angle here, ABD, or you can also construct A and C. Okay, you can join these two things, right? So now I need you to remember the degree measure of an inscribed angle. Okay, now here we can see this is ABD is an inscribed angle. Okay, this is an inscribed angle. So you can say measure of angle ABD is half of, this angle is half of arc AD. Okay, arc AD. Similarly, this angle ACD, the measure of angle ACD is half of, this is half of arc AD. Okay, arc AD. Well, the other thing, we need this one. Okay, BAC. The measure of angle BAC is half of BC. Okay, this is half of BC. Similarly, BAC is half of BC. BDC is also half of BC. Measure of angle BDC is half of arc BC. From here, we need only two of them. Okay, our objective is to prove this angle is half of the degree measure of BC and AD, right? So consider this angle X and this angle Y, okay? To use our space properly, consider this is X, this is Y. Then the sum of these two angles must give us this exterior angle, okay? We have seen the relationship between two remote interior angles and exterior angles. So these two angles will give us angle BEC, or this angle. So X plus Y is equal to the degree measure of angle BEC, okay? But X means half of BC, okay? In place of X, you can substitute half of the measure of arc BC, and Y means half of the degree measure of AD, okay? So half of the degree measure of AD, okay? So these two gives us this angle, okay? So you can take out this half. This is the measure of angle BEC, okay? Therefore, if you take out this 1/2 together, the measure of angle BEC is half of the measure of the arc BC plus AD, right? So, this is the same as this one, okay? This is our objective. Addition is commutative. In whatever order you write these two terms, there is no difference. Therefore, our conclusion from this theorem is an angle formed by two intersecting chords is half of the measure of the arc, the intercepted arc, okay? So based on this, we will try to see certain examples. So let's see the first example. In the figure shown below, our figure is a circle containing two intersecting chords. Say this is A, B, C, D, and the point of intersection of these two chords is E. Given that the measure of arc BD is 40 degree, and the measure of arc AC is say 60 degree, then find the measure of angle DEB. Okay, so in this figure, what is given, the degree measure of arc BD or DB is given. This is 40 degree. And the degree measure of arc AC is given. This is 60 degree. So based on this information, we are asked to calculate the angle, the degree measure of angle DEB. Okay, you are asked to calculate this one. So to know this one, okay, to calculate this angle, you need to apply the theorem that we proved before. Okay, shortly, the angle formed by these two intersecting chords, this angle is half of the sum of these two. Okay, so our answer will be the measure of angle DEB is equal to, you need to directly use the formula that we have derived. So the measure of angle DEB is equal to half of 40 degree, or simply you can write the formula first, half of arc AC plus arc BD. So this is the same as half of AC is 60 degree and BC is 40 degree. And the sum of these two is 100. Okay? So half of 100 becomes 50 degree. Therefore, the angle formed by these two intersecting chords where these arcs are given, okay? So this angle becomes 50 degree. Okay? It's a very simple matter to calculate the angle formed by two intersecting chords if the arcs intercepted are given, right? So this is how we calculate the angle formed by two intersecting chords. In our today's lesson, we have seen three basic theorems. Those theorems are theorems related to circle and inscribed angle. The first theorem that we have seen in this lesson was an inscribed angle subtended by a semicircle is 90 degree. Okay, that was the first theorem. And the second theorem that we have seen today is an inscribed angle subtended by the same arcs are congruent. And the third one is this one. The third one is about theorems that deals about angles between two intersecting chords inside a circle. And we have seen that the angle formed by two intersecting chords inside a circle is equal to half of the measure of the arcs subtending the angles and the vertical angles, right? So these are the main points of discussion that we had today. I hope you enjoyed the lesson. This is all for today. Thank you for listening.
Locked and loaded at the top. Nice and quick through there.